Assalamu alaikum wa rahmatullahi wa barakatuh. I am teacher Doha Yazbeck. I am going to explain to you chapters 9 and 10, sum of vectors, coordinates of a vector. Put the following materials behind you: math copybooks, math book, and ruler. Our objectives are: recognize the definition of a vector, recognize equal and opposite vectors, determine the sum of vectors, prove that 3 points are collinear, determine the coordinates of a vector, determine the coordinates of a vector, sum of vectors, determine the distance between 2 points. First of all, we will recognize a translation. Look to the figure here. Definition of a translation. Consider the figure about a translation, the displacement of the rabbit. Displacement is the movement from one place to another. Look for the rabbit. It is at figure 1 here. It moves to figure 2. This is the displacement. It is the path from figure 1 to figure 2 is called the translation that transforms A to A prime. So we can say that figure 2 is the image of figure 1 by the translation that transforms A to A prime. Now our objective is to recognize a vector. Definition of a vector. The figure or this figure represents the translation of a rabbit from point A to point A prime. This path is represented by vector is A prime. The point A prime is the image of A by the translation vector A prime. It is of origin A and extremity A prime. So vector A prime is of origin A and extremity A prime. Any vector, my students, is defined by 3 characteristics. 1. Direction. What is the direction of a vector? Direction is a line A prime. So this vector A prime, the direction is the line A prime, or any line that is parallel to A prime. Since is from A to A prime, and how this vector moves from A to A prime. Magnitude, which is the length of segment A prime, length 2 centimeter, 3 centimeter, whatever. So the length of segment A prime. You must study these 3 characteristics. Example. Look for vector AB. The direction of vector AB is line AB, or any line that is parallel to AB. The sense of vector AB is from point A to B. The magnitude of vector AB is the length of segment AB. Now, my students, we will recognize equal vectors. Definition of 2 equal vectors. 2 vectors are said to be equal if they have the same direction, their lines are parallel or confounded, the same sense, the same magnitude or length. Example. Vector AB equal to vector CD, then we can say that line AB is parallel to line CD, or points A, B, C, and D are collinear. AB and the semilines AB and CD are of same sense, and segment AB equal to segment CD. They are equal in magnitude. In particular, if vector AB equal to vector BC, then B is the midpoint of AC. Look, my student, for these two vectors. AB equal to vector BC. The ending point of the first vector is the starting point of the second vector. So the two vectors are equal, but they have a common point, so that we can say that B is the midpoint of segment AC. Remark. Vector AB equal to vector CD means that, look my students to the figures here, these two figures. D is the image of C by the translation vector AB. This is the vector AB. As A is translated to B, then C is translated to D. So D is the image of C by the translation of vector AB. AD segments and BC have the same midpoint. Vector AC equal to vector BD, and ABDC is a parallelogram if the 4 points are not collinear, or if the points are collinear, A, B, C and D are collinear, you have this figure. Application. Look to the figure here, my students. Consider the figure below. A, B, C, D is a parallelogram, and D prime is the symmetric of D with respect to C. 1. Determine the equal vectors in this figure. 2. Prove that A, B, D prime, C is a parallelogram. 3. Determine the image of A by the translation of vector D, C. Please, my students, stop the video until you solve the required parts. 1. Equal vectors. Look here for vector AB, DC, CD prime. These three vectors have the same direction, they are parallel, the same sense from A to B, from D to C, from C to D prime, and the same magnitude. Look for vector BA, C, D, D prime, C. Also these three vectors are equal since they have the same direction, the same sense, and same magnitude. Vector AD and BC are equal, and vector DA and vector CB are equal to each other. To prove that AB, D prime, C is a parallelogram, we said in part 1 that vector BA equal to vector CD equal to vector D prime C. This gives us that AB is parallel to CD prime. These two lines are parallel, and AB is equal also to CD prime. So we can say that AB, D prime, C is a parallelogram by pair of opposite sides are parallel and equal to each other. 3. The image of A by the translation of vector DC prime is B. Now our objective is to recognize two opposite vectors. Definition. Two vectors are called opposite if they have same direction and magnitude but opposite senses. They are in opposite senses. Yani the beginning start of the second vector is the ending start of the first vector. Example. The path from A to D is different from the path from D to A. Pay attention. A to D here, D to A. These two movements are opposite senses. We can write vector AD equal minus vector DA. Application. Determine the opposite vectors in the adjacent figure. Please, my students, stop the video until you solve the required parts. Solution. Vector AD equal minus DA equal minus CB. Vector AE equal minus EA equal minus vector BE. Vector AB equal minus BA equal minus CD. Vector EB, this vector equal minus BE equal minus EA. This is your homework. Thank you.